G'day everyone, welcome to Education Central here at Sacred Heart College, Kyneton. Mr. Tucker here, going to speak to you about the Bohr's model Bohr's model of the atom, not the element, the atom. We know that elements are made of how many atoms? Well, a lot. Alright, so I'm going to disappear from the bottom here. So keep in tune, listen to what I say, and you'll be good. Thanks guys. So a bit of revision. I just want you to do this individually or with a pair. What is the number of electrons, protons, and neutrons in the following elements? So S, or sulfur, I will go through that very quickly with you so you know. I can do it with my finger. So number of electrons and protons is that number, which is what? That is the atomic number, which is the number of protons and electrons in an atom. Now to work out the number of neutrons, we know that the mass number, that one, which is mass, or atomic mass, either way, is the number of electrons and protons in an element, or in an atom, sorry. So 32, rounded down, 16 protons. The mass number is 32 minus 16 because there's 16 protons and an unknown number of neutrons. So we have 16. So 16 in that. 16 and that, 16 and that. Beautiful. You can work out those two. K, potassium, and AS, arsenic, I think. Good luck, guys. So this guy called Niels Bohr, back in the day, he added a bit extra. We know up until now that the electrons, I guess, orbit the nucleus, which is in the middle of the atom. And the nucleus contains, yeah, you got it, the protons and the neutrons. So these electrons orbit the nucleus at set distances from the nucleus. These set distances are called shells or electron orbitals. So the first orbital, which I'll outline in red, that one, that is n equals 1. It should be lowercase n, I apologize. And then we have in blue, orbital 2, and that is n equals 2, or orbital 2. And you get the picture. The last orbital will be n equals 3, and then there'll be another one which I haven't drawn in, which will be n equals 4. What does this mean? So we know that each orbit has a fixed amount of energy, and are named n equals 1, n equals 2, n equals 3, n equals 4. So electrons from a particular orbital, so electrons in n equals 1, which is this one right here, will have a certain energy, and that'll be the same. But it'll be different from the ones in here, in n equals 2. Okay? So each orbital can only have a certain number of electrons. N1, so the first shell, can only have 2 electrons. N2 can only have 8 electrons. N3 can only have 8 electrons, up until calcium, and N4 can only have, or can have 32 electrons. So I want you to copy down the table in the next slide into your books, because I think it's really important, and it'll really clarify this. The thing that you want to realize is that electrons will not exist in between the orbitals, so there won't be one in between N1 and N2. They need to be actually in N1 or in N2, and they fill up the most inner orbital first. So the most inner one is this one, then it goes this one, then it goes this one. Okay, so 1, 2, 3. Then they gradually fill up the next orbitals and so on and so forth. So copy down this because it's really important. Pause it, copy it down. You only need to know up to calcium. So we'll go through calcium a little bit later. So valence shell, just so you know, is the outermost shell that is occupied by electrons. I'll get you to tell me what the valence shell is. So for example, so how many neutrons, protons and electrons is there in helium? And if you know that, you can tell me how many electron shells they have. And I want you to draw an electron shell diagram of that, please. This is really important because it will come on your exam. So 2 protons, 2 2 neutrons, 2 protons, and 2 electrons. So how many electron shells will it have? We know that N can have 2 electrons in it, so you only need 1 shell. So you'll have your nucleus like this with P, which is a proton, and should really have yellow because that is the neutron, and red is the electrons. Good. So I guess the reason why I'm using different colours is because it makes it a bit easier to see. So the electrons that can fit into the first shell would be 2, and we only have 2, so we only need 1 shell. Pretty straightforward. And the electron configuration, which is something we'll cover a little bit in the next slide, would just be 2. Alright. So, for example, oxygen. The atomic number is 8. The atomic number is the number of electrons and the number of protons. And the atomic mass is 16. So the number of neutrons is 16 minus 8, and that equals 8. So in the center, we do, what, 8N, sorry if you can't read that, and in blue, should be 8P. We can draw some electrons in, there should be 8 of them, so 1, 2. The first shell's filled up, so we need to move into the next shell. So we've used up 2, therefore we have remainder 6, so 1, 2, 3, 4, 5, 6. Notice that I spread them out kind of evenly. This is why. If anyone can tell me why, I'll give you a blueberry candy. Cool. So, how many electrons are in the valence shell? Remember that's the outermost shell, and in this case that would be this one, and equals 2. And there is 6 in that one. Now remember the number of electrons, or the electron configuration, can be written as the number of electrons in N equals 1, the number of electrons in N equals 2, and in that case this would be 2, 6. 2 comes from that one, and the 6 comes from that one. So I want you to have a go at doing this. Potassium, so pause it here, just have a go at trying to figure it out yourself, and I'll go through it with you now. Cool. So we know that in the first shell we can fit 2 electrons, so let's draw them in. 1, 2. Then in the next one we can fit 8. 1, 2, 3, 4, 5, 6, 7, 8. So far we fitted in 10. That's good. Next one. So for the next one, we know that up to calcium you can only fit in 8, so we'll fit in that because we have 10, you can fit in 8, but there's going to be 1 left over. So we'll fit in the first 1, 2, 3, 4, 5, 6, 7, 8. We have 1 left over. Yep, you're exactly right. You put that into the last shell. So then you have 19 electrons floating around in these shells, and in the valence shell, we just have 1. And the configuration of the electrons would be 2, 8, 8, 1. Beauty. So for questions, can you please complete 1 to 4 on page 47? If you have any trouble, maybe ask 3 before me, or rewatch this video because I think it'd be of use for you. So enjoy! And guys, please ask me for help at any point because I'm more than willing to help you guys. Alright, I'll see you guys later. Bye!